of population variance versus sample variance, and I want to give you a visual for what the sample variance would be like. So, what is variance of x? Well, in order for you to calculate the variance of x, you will need to know the PDF of the population. You'll need to know the distribution of that population. And let's try to fully understand this formula that was given to you in your lectures. This is expectation of x minus expectation of x, all of this squared. Okay, that's what that is. So, if you think about this, x is a random variable, right? This is a random variable. It has a distribution. If I have the PDF of that random variable, I can calculate the expectation of that random variable. So this thing here is a population parameter. Population parameter. If you think about the x minus expectation of x, this population parameter is also going to be a constant. I don't know what it is, but it's going to be a constant. So when I do x minus expectation of x or minus a constant, what I really get is that this orange thing is another random variable. How would you describe this random variable? Is the distance from the mean. We shouldn't really call it mean, but let's call it mean for now. It should be the distance from the expected value of x. But let's for now just call it distance from mean or expectation. You can think of it as mean. It won't do much harm. It won't do any harm for this course. Okay, so that's a random variable. Every time I pick a value of x, right? So if I go back to this bit here, if I pick a value of x that's 175, okay, how far away is that from the mean? Is 0.25, right? If it's 1.5, how far is that from the mean? 0. Okay, and this distance can be positive or negative. If I square it, this is also a random variable. It will also have a distribution. What will this tell me? This is simply the distance squared. So this distance squared, which is also another random variable, as also a PDF, a probability distribution function, I want the central tendency. I want the expectation of this whole thing. So what is the variance intuitively? It's the average, right? I shouldn't really call it average, but it might be easier that way to think about it. Average squared distance from the mean. So this variance is also a population parameter. Which will be constant. It's whatever that population parameter is. Now, imagine that now I give you a sample. I give you a sample of stuff, which is x1, x2, all the way to xn. Now, this is a sample of observation of this random variable x, and I get this. What will be the sample variance? What will be the sample variance? Sample variance, which I can call variance of x hat, because it's a sample one. So usually when we talk about samples or estimators, we're going to put a hat on this stuff. What can this be equal to? What would be the sample analog? What would be the sample analog of that? Well, remember this is an average, right? Squared distance. So I can write that in words. Average, well, it must be something divided by n if it's average, right? And I want the average squared distance. So all I have to do is really think about x1 minus x bar squared plus x2 minus x bar squared plus dot 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 dot. So that's the average distance squared. I could do this in summation notation. Xi minus x bar squared divided by n. This is my sample variance. I could ask the same questions as I asked in a previous video with a mean. How does this compare to variance of x? Well, for a starter, they will almost never be the same. But what will happen as n increases, this sample population will tend to get closer and closer to the true population parameter. So this can serve as an estimator for this. Can serve as an estimator for the variance of x. And we can discuss properties of that estimator. Is it a good estimator? Does it on average give us the truth? What is the distribution of that estimator, etc., etc.? Note that this estimator is also a random sample, random variable. Why is this a random variable? Why is this, or the sample variance, why is it a random variable? Because every time you're going to change the sample, you're going to get a different answer. Every time you change the sample, you're going to get a different answer. And that's why you get this distinction between sample variance and variance. Now, I want to give you a visual, and I want to conclude this video with a visual of the sample variance. Imagine that I give you some variables, okay? Let's say that this is 0, so 0 is 1, minus 1 is another one, minus 2, minus 3 is another point, and then 1, 2 is another point. Okay, so what is the average? Imagine that these are data points, okay? This is like my x1, this is like my x2, this is my x3, this is my x4. What is x bar equal to? What is x bar equal to? Easy, sum them all up together, divide them by 4. Sum of them is minus 2, divide that by 4 is minus 0.5, if I'm not mistaken. Right, so this would be my x bar. I draw a line like this, and I call this x bar. Okay? And it makes sense, right? If I put my finger where x bar is, and I think of that as a rod with some weight, that rod would be balanced, okay? Those weights will kind of cancel each other out. Now, let me try and give you this thing here visually. Visually, this is what's happening. I take x1 and I say, what's the distance away from the mean? And I say, well, the distance away from the mean is 5 squares. 5 squares away. And then I square this. So when I square a distance, what do I get? When I square a distance, I get an area. Okay? So if you think about it, this is like the first term. The area of that square is like this first term here. I take the second square, maybe with a different color. Distance from the mean is this much. I square it, I get this. I put some yellow thing here, and I say, well, actually this, the green one, belongs to the second one here. Well, the x3 is also easy. I can realize that it's also here. Okay, and x4 also, x4 is 1, 2, 3, 4, 5. So similar to that one, 5 units. So I can draw it this way. So I get this bit here. So if you think about it, what the sample variance is calculating what is the average area of those squares. So it's taking the area of those, how many squares do I have there? 4 squares, because I have 4 data points. It's calculating the area of each square, and it's dividing that by 4. So variance is average distance square, or if you want it a visual, is going to be the average area of those squares. What is standard deviation? What is sample standard deviation? Sample standard deviation. Well, it's the square root of sample variance. Can anyone give me a visual of it? What is this sample standard deviation? Variance gives you the area of the average square, right? Variance gives you the area of the average square. What's the square root of that average square? It's just the length. So standard deviation tells us a measure of the average length away from the mean. Okay? Note it's a geometric average. It's a geometric average because it tells you, imagine that you had all of these squares, okay? Imagine that you had all of these squares and you covered a surface area with that. The standard deviation tells you if you have 5 of these squares or 4 of these squares is how many squares do you need that are exactly of the same area to cover exactly the same surface. Okay? That's the difference between an arithmetic mean and a geometric mean, right? That you're doing kind of like a geometric mean over there of stuff, okay? So really that's what I have here. I wanted to kind of introduce you with a visual of this sample variance and standard deviation. I want you to see a visual, think of it. That's it.